Morning everyone, and welcome to this Fusion 360 tutorial. I'm Chris England. I'm an applications engineer at Man & Machine. Apologies for the slightly late start, not that it's too late, but had a bit of technical difficulty. So today we're going to be looking at the CAM environment in Fusion 360. So we've looked at modeling, and we've looked at assembling, we've looked at some stress analysis with Frankie last week, and now we're going to be looking into the manufacturing component of Fusion 360. So we're going to look at how to plan our CAM strategies. So with a part in Fusion 360, whatever part we want to manufacture, we can jump over to the design drop-down and choose manufacture. So in the manufacturing environment, we have the ability to set up tools, to set up our tooling strategies, to set up various components of the CAM cycle. So I'm going to start by showing you the tool library. Clicking on tool library, it brings up my tool library window. And essentially here we can create our tools. Now, this is generally based on what machine you're using or what tools you have available with that given machine. So if I click on my local libraries, I can click on CAM. And you can see I've got a couple of tools here prepared. If I wanted to add a new tool, I can simply click on new tool at the top here. And then I get to choose from a bunch of selections here. Now, the only important thing to do is if you're not too sure, well, I'm sure you'll be sure at this stage what tool you wanted to use, but if you choose milling, you'll be locked into the milling tool types. If you choose hole making, you'll be locked into those. So, for example, I'll just choose a bull nose cutter, and it brings up the create tool window. Within this window, we can set some general properties to the tool. Things like description, vendor, product ID, and product link. Now, this is more important if you are in a manufacturing environment where you want to actually create a setup sheet at the end to issue with your job. If you're not doing that, not too important to fill in those properties. If I go to the cutter, so at the very top we have type, and this is where I meant if you lock into the milling, you only get the milling tool options. So you can see that we can change to a ball end, chamfer mill, flat, or whatever we want here, but it's locked within those milling tools. I can choose my units, so either millimeters or inches, so metric or imperial, and I can choose the number of flutes on my tool. I can also have a look, well, in my geometry, I have the geometry of the actual tool. So if I went and selected diameter, it shows me the parameter or the dimension that I'm dealing with. Let's go and set that to 16 for now. And you'll see as I enter it, my image of my tool actually updates. So on the shaft, it looks a bit funny with a 10 mil shaft and a 16 mil diameter, cutter diameter. So we'll set that up to 18, or perhaps just leave it on 16. We can see how that updates. Then when I go to my overall length, you can see that this is the length from the top of the cutter right to the bottom. And I'll set this to, let's say 125. Now I've got to deal with my shoulder, length below holder, sorry. And that's pretty much everything that's not in the holder, so what's sticking out of our holder. I'll set this to 105. Shoulder length, so this is up to the height of the shoulder. We'll set that to 75. And our flute length, so our actual cutter face, we'll set to 50 in this case. Now, depending on what tool you have, there might be more, or what tool you've selected rather, there might be more options that you can choose here. And we have corner radius for a ball nose cutter, so our radius on our corners, so we could set that to 1.5, for example. So with that, we could actually go and, if we wanted a more accurate representation of our tool, we could actually go and edit or change the shaft. So by adding in areas of the shaft, we can then get an upper and lower diameter. So we could go and change the upper, for example, to 15, and you'll see that we get a taper. I don't want anything in. I'm fine with just my generic cutter, so I'm just going to go and delete that. But yeah, it's not too important to set up your tools directly or exactly like they look in real life. I suppose if you wanted to get close precisions and you were trying to do some clash avoidance, then it can be helpful. But for the most part, as long as our diameter is correct, the G code will plot out correctly. So if I go to the holder, we have a bunch of sample holders that we can use. There's many in the sample library. We can create holders as well. So just like we can create tools, we can create our own unique holders. And if I go and select, let's try the BT30 and add it in there, we can see the holder then coming into the tool. Once again, it's not too important to add the holder. So if you don't want to go through the effort, it's okay. But if you are, once again, working with small tolerances or tight tolerances, it can be quite handy to have the holder in for collision purposes. If I go to the cut-in data, this is where we can go and set the speeds and feed rates of our tool. So we can do this on the fly per toolpath, which I'll be showing you shortly. But it's nice to have the general speeds and feeds. And we can also go, and this is a newer feature in Fusion, we can go and add presets. So we could have a preset speed for cutting wood, for example, and one for cutting steel or mild steel and stainless steel. So it's quite nice to be able to have a couple of presets that you can just choose. So you have your optimized feed rates for speeds and feeds for given materials. And lastly, if I go to the post processor, it just has things like my tool number, which is obviously very important if we have a turret, or I suppose for the settings of our machine. So that'll be the number that it calls. And then the length offset and diameter offset are not actually in millimeters as we might expect. It's just the diameter or length offsets that the tool would save for the preset of tool number 2. So you can see that it matches the same as our tool number. So because I'm not going to be cutting anything, I'm just going to leave that all as the default for now. I'm going to say, okay, my new tool is now there. If I wanted to edit it, I can edit. And if I wanted to go and grab, we have our tutorial libraries, our sample libraries. We can always go and copy a tool. So perhaps I wanted to take this chamfer mill, for example. I could copy it, come to my CAM library and paste it. As we can't edit any tools in the standard libraries, sometimes it's quicker to just copy one and then we can go and edit that tool and just change what we need to change for our requirements. So with my tools set up, I'm not going to need any more tools than I have. So we've got our part now. So in CAM, we have some pretty standardized steps to creating a toolpath. So the first step is always going to be to get our setup right. Our setup is essentially creating a stock or creating our stock boundaries. So we can see when I click setup, my menu appears and I have 3 tabs. And at the top, I have the option for my operation type. So I can choose milling, turn-in or mill turn. So both in the same, we have cut-in and we have additive. So we're going to stick to milling for now. We're just going to be doing some 3-axis tooling today. And when it comes to my work coordinate system, we set up our tooling system or our coordinate system for our machine. So by default, this is set to my model orientation. And normally, if I'm going to be machining a part, I like to model it with my Z being up on the part so that, I don't have to tinker around too much here. But if I needed to, I could change orientation and say perhaps select Z axis or plane and X axis. This allows me to have individual selections for directing my Z axis or directing my X axis. So, for example, if I wanted my Z to come forwards, I could just select that face and it'll go normal to the face. Or if I wanted my X axis to go up, I could choose an edge. If I choose an edge, the axis will then go along that edge. So if you're choosing faces, it goes normal to the face, and if you choose an edge, it runs along that edge. Now, like I said, I've already modeled my part so that the model orientation is ready to go. And then it's just a matter of selecting the point that we want it to sit on. So a lot of machinists like to face off first and then actually set their 0 coordinate to the top of the model rather than the top of the stock point. So we have options here where we can choose our origin. And we can choose something like model origin or selected point or box. So I'm going to just choose model box point, and you can see that my nodes just drop a little lower based on my stock, so they're just below the stock surface to the top of my model. And on a part like this, I'll leave it at the center. Then I go to my stock tab and I can choose my offsets. Now, because once again, I'm not machining, I can just use the relative size box, which just allows me to offset the general bounding box of my part. But if I had a piece of stock in mind in the workshop that I wanted to cut, I could say fixed size box and then actually fill in the dimensions of that stock material. I'll just leave it on relative size. I want to leave a bit of a bottom offset. So we'll go 5 and you can see it extends at the bottom. And I'll just leave 1 millimeter on the top and the sides. Post-process tab is mainly just to set your program number up front. We can do this later on as well. So if I say OK, we now have a stock and we're ready to start plotting toolpaths. So normally our first toolpath in just about any tool or CAM setup is to go and do a facing operation. So if I choose the facing operation, first thing in the menu that we get to do is select our tool. So if I jump to tool, I can click on my CAM library and I can go and choose my face model. If I say select, it'll come in with any speeds and feeds that are set to that tool. Like because this is a standard one, it doesn't have any particular setups, but it's fine for our purposes today. And if I go to geometry now, we can choose the geometry that we're going to be machining. Now, when it comes to facing operations, it's generally pretty standard. We just go down from the top of the stock to the top of the model height. So whatever that height is, and we're just going to pretty much cut a flat path. So normally we don't have to select too much on the facing operation. So I'm going to leave that as is for now, and I'm going to jump to my heights. Now, heights are quite important to set up. If we look at the main two being top height and bottom height, the rest, the feed height, the retract height, and the clearance height are mainly just for rapid movements and such. So as long as that's clearing your part, you're pretty much good to go. But from the top height being our stock tops, that's where it's going to start cutting, and the bottom height being the model top, that's where it's going to cut to. So that's fine. That's all set up as we want it. If I go to passes now, we can see that multiple depths is ticked. So I can say step downs of, and we know we have 1 millimeter on the top there. So a step down of 0.5 millimeter will be 2 steps. So we'll leave that as is. We can choose things like step over. So that's how many times it will step to the side, or what distance increments it's going to step to the side rather. And if I say stock offset, I like to add stock offset because that's the overlap on the end, and normally the tool will line up with the edge exactly. So if you leave a little bit of an offset there, just make sure that you don't get any cusps. So if I go to the linking tab now, this is just our lead ins and lead outs. So normally by default, our lead in and lead out will be a radius of some sort or another, depending on the tool strategy. And normally it's roughly 10% of our cutter diameter. So we have a 50 mil face cutter, face cutter, and we have a 5 mil radius. So I'm going to leave that all as is and say OK. And we can see it generates my tool path. So from here, I might want to check that. So I can always go and select, and I like to run a simulation from selecting the setup rather than the individual toolpath, because you'll see once we've stacked a few toolpaths, you may leave something out and your collisions wouldn't be accurate. And if I have a look here and I click simulate, I'm just going to move this over to the side so we can see. I click simulate, we have some options here. So we can say display stock, we could say whether it's transparent or not. Transparent's nice so we can actually see our finished part. And we have some options for how our toolpath looks as we go. If I click play, it just runs the tool through that toolpath. I'm going to speed it up a little bit with this bar here. And that's pretty good for a start. So now that we've done our facing operation, it's time to do some contouring around the outside. So I'm going to start with a 2D contour. And the same menu appears. So with most of our toolpaths, we look at this sort of 6-button or 6-tab menu. I'm going to click select tools. I'm going to click on cam again, and I've got a rather long but necessary for this part flat end mill. I could use the one that I've created if I wanted to. In this case, I'll just use this one, which is a 20 diameter flat end cutter, or an end mill as most of us know it. And once again, my speeds and feeds, I'm not going to worry too much as I'm not going to actually machine it. Now, with the 2D contour that I'm using, we need to select a boundary. So I'm going to select the outside edge there. I'm not selecting the bottom because I want it to go to that bit, and we'd flip it over later on to bring in the other side. So that's fine for now. I'm going to go and select my heights. So with the heights here, the top height, because we've already faced down, we can set to, rather than stock top, we can set to model top. And you can see that the bottom height is set to selected contours. So it's going to go down to the contour that I selected in the second tab. So that's perfectly fine for now. If I go to passes, it's slightly more complicated than what the facing operation was. So I can choose things like multiple depths here, and then I can choose my roughing step down. So I'm going to choose 2.5 mils just to speed things up a little bit here. And I'm going to say finish only at final depth rather than stepping down the finishing steps. If I carry on and go into the linking tab, once again we have radiuses for our lead in and lead out, and we also have a lead in sweep angle, which I'll just leave as the default for now. So if I say OK, we can see it generates our toolpath. Now that's all fine. Let's have a quick simulation just to check where we are. I'm just going to skip that path and just look at the one that's I'm concerned with now. And we can see that it's leaving some cusps there on all the corners. Now, in most cases, that would probably just break off, but it's probably not the best practice to just let it break off like that. So we're going to need to remove that too. So what I'm going to do to remove that is I'm just going to duplicate this 2D contour that I have already. So just right-clicking on it and saying duplicate. I can now get a second one. Now I'm going to edit the first one because the second one's exactly the same, and I want this to happen before I start the next stage. So if I go and edit this strategy, I can go and change my geometry, and instead of doing the whole contour, I'm just going to click cancel there, and I'm going to hold down Alt on my keyboard, because if I hover over it does the whole loop, but if I hold Alt on my keyboard, it allows me to select individual edges. So holding Alt, I'm just going to go around and select just the corners because I don't want to waste too much time circling right around. I could add a roughing pass and then just step it over, but in this case, it would be quicker to do it this way. So if I go and leave my multiple depth settings, so you can see that it's persisted from the duplication. And I'm just going to go and add stock to leave in this case. I'm just going to leave, let's say 4 mils stock. And then on my axial, I want to go right down to the bottom. So I'm going to set that to 0. If I say OK, you can see that I get a contour there. So if I just quickly simulate again, we can see that it should remove those corners for us quite nicely. Right, so I'll just speed that through and we can see, and then jumping around. Now we don't have those edges hanging out. Good. So if I close that, we can now move on to the next bit. So I want to go and run a contour through the middle. Now we don't have too much time, so I'm gonna run through it quite quickly. We're going to run just another 2D contour, and I want to select just that edge there. And we can see because it's a 2D, even though I'm selecting a 3D edge, it comes out as flat from a 2D perspective. I want to be careful of my heights here because on my selected contours, it's obviously the bottom is the bottom of that pocket, and if we run a contour through it, it's just going to run straight through. I'm going to say selection, and I'm just going to go down to that height there. And just on my geometry, I want to add a tangential extension. I'm just going to add 10 mils onto that. Right, I'm going to use the same multiple depths that I used before, and I'm going to run it at 2.5 drop down. And lastly, on my linking, I just want to come in straight because I'm plunging outside the part. I'm going to just turn off my lead in and lead out. Say OK, and it generates some clearing there. I might need to step into the middle, but I won't worry too much about that for now. I could do it by editing and just saying roughing passes on. And now, because I've only got one step over, I need to move the finishing step over, which I'm going to just set to 5 millimeters, and that should give us enough to clear out the middle of the part. Good. So now we want to look at clearing out just the bottom of this pocket. So I'm going to use a 3D pocket. Now, using the 3D pocket in this situation allows me to actually fit to my geometry rather than just using a standard 2D pocket, which would just cut straight down into the profile. So I'm going to select I'll use my flat for this to clear it out quite quick, a bit quicker. And instead of saying bounding box on the selection, because the selections work slightly differently in the 3Ds, I'm going to say selection, and I'm going to choose the inside of that pocket. Now, with the 3D toolpaths, it's generally quite a bit more intuitive than the other ones. So I'm just going to make sure that my tool stays inside my boundary, so center tool inside boundary. And I don't really have to set up any of my heights in this case. I'm just going to make sure that my step down, so I'm going to leave a bit of stock, so we'll have some step downs on the edges. And pretty much that will do fine. I might want to have my, just looking for it, my roughing step down a little higher, but I think 1 millimeter, let's say 2 millimeters there. Now, linking, because it's a pocket, we can choose a ramping. And we have different cycles that we can use there. Helix is normally the most common and is my default. And we'll just say OK. All right, so we can see that our height, it's wasting a lot of time. We could have pocketed that in the beginning, but we've already cleared that out. So I'm just going to quickly edit, change my heights, and change from stock top to selection, and just start from that height there. Maybe add in 1 millimeter clearance. So saying OK, you can see that it's generated a lot less wastage there. Right, so now I might want to clear the rest of my area around these two wings here. So I'm going to use, once again, a 3D strategy, as it's not just simple 2D geometry, and I'm going to use my adaptive clearing cycle. So using the same tool will be fine. We'll just go and choose our area. So I'm going to take stock contours off and choose my boundary to be the silhouette. And I'm going to let my tool go onto the center of the boundary and not on the outside. I can use rest machining here, which means that it looks at the previous operations and pretty much generates based on what's been removed already. If I do save from previous operations, I'm going to change my step downs. So stock to leave once again, because these are roughing strategies, we leave a bit of stock and then we'll come and finish them off. And if I look here, I've got both a roughing step down, which is quite large. So I'm going to put that down to 2.5, and I'm going to look at my fine step down, which is anywhere where it has a curve or angled edge, it'll step down at a smaller jump so that we get a finer finish there. I'm going to generate that and see what it looks like. Now the adaptive, because it has a bit more to calculate, is going to take a bit longer. And in fact, to limit it a bit, I'm just going to quickly edit my heights, and I'm going to change my height from my model bottom to selection once again. I just want to stop it over there. Say OK. Now, while it's generating, we don't have to wait for it to generate. We'll come back to that in a second, as time is running away with me. And we can start doing some of our finishing strategies. So first one I want to look at doing is a parallel cycle, just to run through here. So I'm going to choose my parallel from my 3D dropdown, and I'm going to start using a ball nose cutter for some of my finishing. So I've got a ball nose here, also nice long overextended tool so that we don't have any clearance issues with our holder or any collisions with our holder. And I can then once again go and change my machining boundary to selection. I'm going to select this pocket once again, and I'm going to allow or keep my tool inside the boundary. Now, because we're finishing, so I don't have to worry too much about my heights because of being a 3D strategy. But because we're doing a finishing, we want to change our step over to something quite fine. So we'll go with 1 millimeter. Once again, we could look at our linking, but for the most part, it's just radiuses on lead ins and lead outs. And with the parallel, we do have the option to either go direction both ways or one way or the other way. So up and down, and we can also change our pass direction. In this case, we want it at 0 because it's going to run along our x. So I'm going to say OK, and we can see that we have that strategy there. Right, so now it's just about, all right, so our adaptive has finished. Let's have a quick look at where we are in our simulation. We'll just skip through it so we can see the end result. I'm going to hit play, skip through. You'll see once it gets to more of the complicated strategies, we have a loading bar at the bottom that then needs to catch up. That's okay. So we'll just have a look at what our finished product looks like. It's not too bad. We could probably have gotten a slightly higher quality finish on our adaptive, but due to time, we'll just leave it as is. The finishing strategy will clear it, although probably not best practice. But looking pretty good on the pocket there. So the last little toolpath that we're going to add here is our scallop. So we're going to use a scallop to clear out these wings, or to finish these wings rather. So I'll leave it on my ball tool. The tool selection does persist from the last generated toolpath. I'll have a look at my geometry once again. Now, I'm not going to worry too much about changing my geometry because it will generate. I'm going to leave it on silhouette. I'm going to leave tool center on boundaries on. And if I go to my heights, I'm just going to limit the height of the bottom height to the same height there. So I'm not wanting to go into that pocket as that's already finished. So we'll do that. Now, another thing I'm just going to add is on my geometry tab with the 3D strategies, we have avoid touch surfaces. I know from experience that it's going to go and run right around the edges. So to save a bit of machining time, I'm just going to add some avoid surfaces. We've already gone past these ones. So pretty much I just wanted to focus on the wings, on the top of the wings rather. So once again, step over, I want it quite fine so that we can get a good finish. And lastly, linking is okay as the default for now. So I'll say okay and let that generate. So we can see we get quite nice coverage of those wings there. So last little step of the machining toolpath, as we don't have too much more time. We'll just go and play it through, make sure that we're happy with all the results. Skip, 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 skip. Right. And although probably not ready to be finishing yet, the finishing will clear off the last of that. So we'll just speed through that. You can see I've got a couple of collisions here. And if I hover over the little red bits on the collisions are actually behind my camera in the feed. So apologies for that. But if I do hover over them and you do get any collisions, you can always hover over and you can see that in my case, I've got a rapid collision with stock, which is fine. It's just because I didn't clear out enough. So we have a nice finished part at this stage, and we're ready to go and post-process. So once we've gone and done all of our strategies, the next step or the logical step is to post to G-code. So if I select my setup once again, if you select any individual toolpath, just like with the simulate, it's just going to work with just that toolpath, whereas we want to do the whole setup now. So I'm going to click on my post-process on my actions panel here, and it brings up the menu to post-process. So in my post-process window, I've got a configuration folder. That's where all my posts are stored. So if you have a unique machine or a unique post process that you want to use, you go and paste it into there. You can see because I also use InventorCam, mine's just set to the same library as InventorCam, so I only have to put my posts in one location. And we have a drop down here for post configurations where we can choose from multiple different machining types. There's quite a lot from the default library, and you can also go and get more, or if you have a unique machine, you're welcome to contact us to try and help you with post-processor editing. Either way, we have our output folder here. So I'm going to just use a default Fanuc post-processor, and we have our output folder, which we can set to any location. It will persist from the last place you posted to. And I can change my program name or number. So that was something that came up in the setup when we originally did it. So if you set it in the setup, it'll persist to that. Otherwise, you can just post as a once-off. So I'm just going to set this to some random number because I post a lot of posts. And we also have some properties here. So these properties can help you with certain features within the post processor, switching them on and off. So I can write machine, write tool list, preload tool. There's things like sequence number or sequence increments. So that's a line number that it will add in. I might want to turn that off completely. So I could say use sequence numbers no, and then I won't get any line numbers. So I can also select open NC file in editor. And if I say post, it allows me to save the file, and I'll just say save. Oh, we've got a problem. Program number is out of range. So my program number is a bit long for the post processor I've used. So let's quickly just go and change that. We'll just go and say number 2 should be fine. So okay. So put up in my other window. So there we go. Obviously, the first one failed because I went with too many digits. It's only got a 4-digit capacity for the name. Either way, if I go and have a look, we can see our G code being processed or output. So we have phase one operation, contour, and all the other operations. It's quite long as we have quite fine tolerances that we've used with very fine stepovers. So it's got quite a lot of code in there. And that's then ready to go to your machine. So you could save this onto a USB, or if you have a direct input on your network, save it onto your network drive, and your machine will be able to pick it up. Sorry, it's been a bit rushed at the end here. We have run out of time, unfortunately. But yeah, that is the CAM environment, and I hope you enjoyed this tutorial today. Thank you very much for joining.